Hi everyone. So I think, just looking at you all and based on the previous lecture we had, we are all here for one cause, taming this beast of LLM. This is why we are here across the entire day, how we actually tame the beast. So I'm Lior Sidi. Until recently, I was leading AI research at Wix in the field of natural language processing, fine-tuning of LLMs and LLMs in general, and knowledge representation. And today, I'm starting a new venture, pretty much related to similar fields, but if you want to talk later, let's talk. So today's lecture is it's actually very much linked to Julian's talk about fine-tuning LLM, but today we're going to talk about Wix's journey of how we actually applied it in enterprise use case. A lot of considerations needed to be taken, and of course, best practices, methodologies that I think can be useful for everyone, not only AI researchers, but mostly developers who want or starting working with AI and customizing LLM and trying to tame the beast. So before jumping into the techniques, let's understand Wix. If you don't know, Wix is an amazing platform for creating your own online presence. It goes beyond building websites. It's also for managing your business, collecting payment, managing your workforce. So we have a lot of use cases. And when we started using LLMs, like we were one of the first adopters, and actually the data science group goes way back a few years ago, doing a lot of AI on the Wix platform, both for our users and users of users internally. So when we started adopting it, actually it was even before ChatGPT, it was already in the previous GPT's models. You know this framework, we have a prompt, we have an LLM, and we want to use prompt engineering. So for example, in case we want to, given a user, we want to understand which is the most relevant Wix feature for it. So if I'm going to use GPT out of the box, so given a user, let's say I'm looking for an editor of building website for agencies and enterprise, and I'm going to put it into my prompt inputs. I'm going to ask GPT, and I'm going to get an answer, what we call zero-shot inference. And the results is, you can see on the left, is editor X. So editor X might be the right answer if you lived 2 years ago. Today we actually have a new editor called Wix Studio, which is more relevant for agencies and enterprises. So actually these models are not up to date, and we need to tame them. We need to custom them to our needs. Another use case is, let's say I want to understand what is the next best action for our users, and we want the LLM to grasp and understanding our best practices in how to recommend actions. So let's take a user, for example, a jewelry store with low traffic and good conversion rate. If I'm giving it to the LLM and asking for an answer, this is, by the way, real examples, I'm going to get, you better have, might recommend to him to have high quality visuals. So not mentioning that, it might be, you can add visuals to your website, but actually it's not really relevant to the user. The user already have good conversion rate. It's all about getting more traffic. So we basically want to, instead of having good visuals, we want to improve the SEO, we want to have Facebook ads, basically totally wrong business logic behind these LLMs. And I hope this is not new for most of you, okay? And today we're going to talk about how we're actually customizing this. So if we're looking at these two main components that we have the prompt, we have the LLM. Let's start from the left side with the prompt. Until now, we talked about prompt engineering. So we can improve the prompt, we can add more knowledge, code it into the prompt, give more guidelines, endless work, repetitively. It's not really changing, not up to date, but it's possible. It works very well. It's simple. Another way is using RAG. Who knows what is RAG? Please raise his hand. Okay, a lot of people here. For the one who are not familiar, RAG is a way that you actually combine your domain knowledge into the prompt. You actually query your databases for the relevant article, the relevant text, and inject it into the prompt itself. And then, for example, if I ask what is the next best action, I can maybe extract relevant actions that appears in Wix and then put it into the prompt and recommend, etc. Or even the most common use case is basically question answering, right? Another way is to do prompt optimization. A lot of libraries in this field, when you have sort of feedback about the correctness of the prompt output, assuming you have it, you can actually iteratively improve the prompt itself and let maybe LLM, maybe another automation process to optimize the prompt. Cool? So these are all in the field of trying to improve the prompt. Today, we're going to talk mostly about how to improve the LLM, which is exactly what Julian was talking about. And when you want to improve the LLM, you actually need to start doing fine-tuning. And fine-tuning is a big word, and we want to break it down to different type of fine-tuning because we know it might be very confusing for someone that's just starting. So let's differentiate between first what we call one-task fine-tuning. Basically, these kind of fine-tuning, it's what is accessible for you in the vendors like OpenAI. When you're doing fine-tuning, you actually are fine-tuning for one task, for one prompt, which is much smaller, that allows them to do that. But if you're adding multiple tasks, basically it won't work, okay? Eventually, they need to scale this service in a way. Another approach is called alignment. I won't go deep into that, but it's mostly about if you want to improve holistic capabilities, tone of voice, general capabilities in the LLM, and you want to use sort of, if you know RLHF and etc. So alignment is another topic. And the topic that we're going to talk today is the multitask scenario. In multitask, or AKA domain adaptation, not the domain from building website, but domain. Domain adaptation is basically when you have multiple tasks, you have your own domain, let's say website building, let's say coding in a certain language, and you want the model to adapt to this domain, and then you want to solve multiple tasks at the same time, or to have a model that can do many tasks. And Julian also showed it in MergeKit, by the way, when he took different models and merged them together, so it's more or less in the similar scope. So if I'm comparing for you, because I think it's, you have all these techniques and you want to understand where they sit. So you have this complexity world that you can, how much development, how much data you need to have versus how many skills the LLM is going to have. So on the bottom left, you have the prompt engineering, right? So it's like very simple, not that complex, but very limited with its skill set. And on the upper right, you have the domain adaptation, where we're going to talk about its complexity, but it benefits you with a lot of native skills that you get out of the box from LLM without doing a lot of prompt engineering. But before we start, it's very important for me to emphasize the benefits and pros and cons when we go into domain adaptation or multitask training of LLMs. So, okay, you get natively capabilities in your LLM because you now have an LLM or a smaller LLM. You can run it locally. It might be cheaper. On the other hand, it's from our experience and what we're going to go through today, I'm going to explain how hard and expensive it might get. It's available only on, if you really want to do it, you really need to work with the open source model, which are good, but you don't get the all set of capabilities that you can get from the closed vendors, like OpenAI, like Anthropic. And these models, OpenAI and Anthropic, are reasonably very, very good and becoming cheap, so it's a trade-off. Okay. So when you want to domain adapt, so let's focus about domain adaptation. If you want to adapt an open source model, you first need to start with the base model. Choose your model, and we're going to talk about two different types of models. You can have a totally empty model without any weights, or a pre-trained model. Pre-trained model can be like a model that's already trained on a lot of data, that usually this is what you get from a llama, or or Llama or other vendors, or you can get it pre-trained on certain alignment, let's say chat capability. So you have Llama free chat, okay? So you need to choose the base model based on your use case. Then you have a very big and expensive process that is called domain adaptation. It's where you training the entire network with your domain data. You need billions of token data. It's a lot of data that you need to train in order to, especially if you want to train from scratch. Then you have the supervised fine-tuning, is where you have a bit less data, but still you need a lot of data, but on these specific tasks that I mentioned. It's called SFT, also mentioned. And lastly, you have your adapted model. So you have these two steps of training. First, you want to train on the entire domain data, if it's a totally new domain. For example, NVIDIA presented a chip NeMo, and this paradigm taken from them, where they want to adopt a model for the chip industry. So they first, LLM didn't know a thing about, or very little about the chip and hardware, so they need to train from scratch on their data sets, and then they move to solve specific tasks. But the real problem is that we need to understand our limitations. And at Wix, we don't really have billions of data tokens that we can share. We have a lot of maybe of private one, but we don't necessarily have billions of token-based data that we can use. But on the other hand, we have two benefits in this scenario. One benefit is that LLMs already knows Wix and know the domain of building websites and working with the tools. So this is the main advantage. It means that we can take a pre-trained LLM. The second thing is because, as I mentioned, Wix already have a lot of experience with working with data, with creating benchmarks. We actually have a lot of high-quality data that we gather through the years that we can actually instruct the model. And it's very structured, data-driven company in the end. So this is why you need to invest in it. Eventually, it comes very benefits also here. So eventually, we are left out with these sort of simple process that we are taking a pre-trained LLM, and eventually we are fine-tuning it on many tasks that we have and we curated at our company. Make sense? So let's talk about the high-level process of how we are actually doing it. We're starting left with mapping the different data sources that we are going to use for two processes. The first process is the training. We want to create training data sets where you have the input, you have the output that you want to generate text upon, and you created a training data for your model. The other process is evaluation. Training without a goal, training without understanding the matrices, the business matrices, and the KPIs that you can impact with, it's worthless. So the evaluation part is basically taking your trained model or even the base model and estimate its performance on business tasks, on the tasks themselves. And usually this is a topic that is neglected by many AI developers. But this is the first thing an AI researcher will do in a project. Start with evaluation. And we can talk endlessly, and I was very happy to see that we have a lot of talks around evaluation in this conference, so go into them. We want to start with evaluation. This is our North Star. Without understanding what we are optimizing for, we cannot really train any model and understand the progress. Makes sense, right? So let's start with evaluation. A very cool technique that was presented through many papers, something called knowledge probing. Knowledge probing is when you want to quantify the knowledge of the model, but you don't want to use the free text for estimation. You want to turn it to sort of like a classification task. So what you can do is you take a question, like question and an answer, and you generate three other or another of options. And one option can be very easy, another one harder and harder. And the way you generate it is you are maintaining the same structure of your correct answer, so it won't be biased towards the structure. And you let another LLM to generate, and then you manually curate it, because it's a benchmark. You don't need a lot of data, but it needs to be very high quality. So now you turn a knowledge, like a free text knowledge task into a classification task, which is very easy to estimate the performance, and you get 2 for 1. Meaning that you first get the knowledge capability of the model, and the second, the instructive capability of the model. The fact that the model can follow instructions. It's, okay, you still want to estimate it as well. So this is one way to estimate for knowledge. And when we, just two other examples of benchmark that we used from our internal use cases at Wix was the intent classification. It's a data set or a model that takes the user intent in free text that is handed to us in the chat or in the customer care chat, and we have like label data with the intent. So this is another classification task. And a lot of Q&A, free text question answering pairs on top of the multi-choice that I presented. So for the top two, it's very easy to estimate. You need to understand how you actually estimate the task. So for intent classification and for multi-choice, you can use accuracy matrices and you can quantify it. When it's come to, as I mentioned, for Q&A and generated text, it's become much more tricky. There are different ways to estimate the performance on Q&A. You can have it by human, you can do exact match, you can do similarity score, or another model that score. All of them has some limitations. In the human case, it's not really scalable. In the other approach, they cannot really handle long answers, only short ones, so it's not really scale. And the way the community started tackling this problem is using LLM as a judge, okay? So this is, I hope, as well, it's not that new for most of you, but if you really want to do LLM as a judge correctly, you need to really make sure that you evaluate the evaluator, okay? That you make sure that the LLM, that the judge that you created from by LLM is actually correct in his estimation. And this is something that we have done as well. In this process, you can see, because basically this is the most important part in the building the model. If the scoring mechanism of evaluating the model is not working, the entire process is basically worthless. So what we've done, we generated a sample data set of candidate answers and ground truth answers, and we let a human judge compare between them. So we have a manual annotated data set by human, and we have our different versions of LLM as a judge. And we just computed the agreement between them. When we used simple judging prompt, like you see here, you have the question, you have the candidate, and you ask. Which is, by the way, this is the recommended prompt for LLM as a judge by many papers. When we estimated its performance and agreement with our human expert, we identified like only 50% agreement between them. So it means that it's worthless. So what we can do to improve the prompt? Question, open question. What? Prompt engineering, well done. So we basically added in guidelines of what is being considered a good quality question. We have identified different classes of correctness. Is it equivalent? Is it detailed? Does it have extra information, partial, and totally different answer? This is this chain of thought actually helped improving and increasing the agreement to 76%. And by the way, today there are even better techniques doing that, so read about it. And what we really wanted to look at, it's not necessarily the agreement because it's very high level. We wanted to look at the false positive. The cases where the evaluator said that it's actually a correct answer, but it wasn't. And this is the scenario that we are more interested. These kind of mistakes are much more expensive. And we saw that the false positive are only 2% out of the sample data set that we have, so we gain trust with this evaluator on this specific data set. Cool. So now that we have the evaluation process, the first thing that we are doing, we're estimating the performance of current, of today's base models, GPT-4, 3.5, and Llama 2. So just a remark, this was done on March, like before March 2024, before GPT-4o, and this is something we need to remember to the end because it has a lot of impact on our decisions that we took looking forward. But if I'm comparing the different models in aspect of in March 2024 in respect to cost and latency, so GPT-4 back then was very, very expensive and very, very slow. On the other hand, The Llama 2 13 billion was much cheaper. You could run it on your local machines, on your local instances, and it was pretty fast. And the go-to, I think most of you already don't remember, but it was GPT 3.5. It was right in the middle, had very good performance, and it was pretty good. So it was the go-to model when we did prompt engineering. So this is where we start without any fine-tuning yet, and we estimate the performance of these models on our benchmarks. And we saw, as expected, GPT-4 actually was outperforming by a lot compared to the other ones. Llama 2 was totally off the chart, very bad, and GPT 3.5 right in the middle. And the question we wanted to ask is, can we actually adopt a Llama model, an open source model, to outperform GPT? I didn't mention which GPT, but you understand it's going to be GPT 3.5. It wasn't 4. So let's understand how we are doing that. So we have our evaluation mechanism. We know how to estimate the model. Now let's look into the data. So the first thing that we have done in our company, and something that we maintain but encourage most of you to do that, is mapping your different data sources, raw data sources. And we have three types of families: articles, conversational, and tabular. Each one of them has a lot of different data sets. These are just examples. And we want to categorize them into two types of quality measurements. One is quality, and the other one is the the effort that it requires to generate a task out of this data set. So that's a work that we have done. We have in Wix, we have a role called data curation that actually manage these processes of creating benchmarks, of maintaining the evaluation, and doing error analysis at scale. So this was part of their work, alongside the researcher and the engineers. So we mapped, and it allowed us to identify which data source we want to focus first. The ones that are clean, ready, and have the most impact in creating tasks that are impactful for us. And the question is how we take this raw data and turn it into something trainable. So each one of these raw sources can be mapped to different tasks. So eventually we have the raw data. We wanted to generate a task. Sorry. OK. So for the articles and the conversation, we can actually use, we'll start. From the articles, we can use a technique called reading comprehension that was presented by Microsoft, and we're going to show an example. For the articles and conversation, we can use LLM to generate tasks out of them. And for the tabular data, we can create like rule-based creation of tasks. And let's see some examples, because otherwise you won't understand. So for reading comprehension, you're giving it a text, and you extract different reading comprehension tasks. For example, you have an article. It has a title. So the task going to be given this paragraph, please generate a title. So in this case, the model actually can learn how to extract titles, summaries, etc. Another task, which is shown to be the most beneficial one, is to choose a paragraph that contains a lot of domain-specific wording tokens, and ask LLM, please, giving these words, given these phrases, please generate a paragraph. And in this case, we allow the model actually to learn the relation between terms in our domain and generate meaningful text out of it. And there are also other different reading comprehension tasks that we can create, like cause and effect, entailment. The list goes on. And so it's a very cool technique that eventually we want to have an input, like the task, like the title, given the paragraph, please generate the title, and the output, which is the title itself. This is our data that we're actually going to train on the models. For the rule-based task augmentation, with the tabular data, which is the coolest, I think, process that we have, is to take available data that is meaningful in your organization, for example, our issue system at Wix, and create tasks out of them to understand Wix better. For example, we took the issue system, and we have in the columns in this table, we have mapping between an issue concern and the product that is related to the concern. So we created a task out of it. Another great example is using a recommendation system that you have. So if you have an action or some product or whatever that was recommended to your users and he chose it and it was actually successful, you have this mapping, you can create a task. Given this user that this is how he's being segmented, this is his category, whatever, and he was presented with these offers, what he actually chose, and the output will be in free text what he actually chose. And in this case, you can actually understand business relations and see how they behave. So we have all of these three data sources. We have tasks that we created out of them. Now we want to join them all together into one data set. And this is where we want to sample and balance the data set. When we have this in mind, we basically want to, if beforehand the pre-trained LLM, the amount of information it has on our domain, let's say Wix, was very minor, we want just to increase this portion by some degree, not necessarily have the new model know only about Wix, because then we're getting extreme forgetfulness, catastrophic forgetfulness of the model. We still want the models to contain some general understanding about the world. We just want to increase the ratio of our domain. Makes sense, right? And I can tell you that as an AI researcher, this balancing of data set has become the new hyperparameter of fine-tuning models. This is actually, if you control and understand the balance between the data set, between the task, and understand how to do it well, you can optimize and create better models. This is actually even stronger than some of the hyperparameters that we are getting from what we're going to discuss in the training process. Okay, very important. Maybe I will say one word about it, because eventually this is the data is basically what the model knows. So even if you give crappy data, for example, that has misspellings or whatever, your model will generate wrong grammar, for example. So it will learn everything. So first of all, you want to have a very quality data, and also the balance between them. If you give it too much information on certain domain, he most likely be more focused on it, and will maybe in the recommendation will recommend, will fall into this area. So understanding the balance between your benchmark is super important. Now let's talk about the modeling. This is really connected to what Julian was talking about, and actually he gave you a much deeper intro of how to do it than what I'm going to present. So go back to his lecture or session to understand even more. In a nutshell, we have like 3 steps. First of all, we want to choose the LLM that we presented, the base model. In our case, as I showed, we chose the Llama 13 billion chat. The reason we wanted the chat model is because eventually we want to serve these model that's the custom Wix model as a chat. Okay, this is the reason we chose it. If it was doing just general tasks, maybe I would choose a different model. Then we have the training process, and finally the evaluation. In the training process, we have the full weight fine-tuning, we have the parameter efficient fine-tuning like LoRa, QLoRa, and eventually when we tested all the different combination, we went with QLoRa, as it showed better cost-effective performance. I can assure you that this process is trial and error. And I'm going to show you some example of what you're going to get when you train. But there are different training techniques that you can try, also what Julian presented. So when we train them, the first thing that you want to see the output of your model, and this is what we saw. The first type of issue that we have identified is repetition, is where the model keep repeating some line. Very common mistake that we already know from GPT, the first GPT versions. The way to tackle it, by the way, if you're using Llama models, is to look into your tokenizer and make sure that you modify the end of sentence token, because sometimes there is a gap there. Even training on more epochs can improve this issue. Another issue that you can face is the instruction leakage, where the LLM is actually answering something and then asking itself another question and continue writing more and more. And this is basically, in this case, what you need to do in order to stop this repetition or the instruction leakage is to start by propagating only on the answer and not the answer and the question and the task itself. So finally, if we are comparing the different models that we've gained, so our model is this Llama 2 chat fine-tuning. You can see that is outperforming GPT 3.5 by most of the matrices, still not as good as GPT-4. And when we also tried GPT 3.5 fine-tuning, where we tried using OpenAI fine-tuning capability, we actually really got bad results because, again, the GPT model fine-tuning process is aimed for one task at a time, not on many tasks at the same time. So summarizing, I have 2 more minutes. So first start with the sources, mapping them, creating evaluation process, modeling, train your models. So in the data sources, make sure that you have high quality that are available for creating tasks. Invest in evaluation. Invest in evaluation, and of course, try different training models, training mechanism. Bottom line. So through this journey, we gain a lot of experience, and I can tell you that the most beneficial part was creating the benchmark and the evaluation process, because we have this asset that we can take any model that any model or vendor, we can estimate its performance on weeks. As you know, most of the leaderboards that you have in Hugging Face are already overfitted by the vendors, and you want to have your own data sets to estimate the performance of your models. Despite the increased performance that we gained from using Llama, eventually we chose to focus more on the knowledge part of how to represent knowledge, improving RAG. The reason for that is because we got GPT-4o and more advanced modeling that actually, despite the fact that we were doing fine-tuning, weren't actually keeping up with the pace of improvement that we got from the vendors' models like GPT-4o. But I will say that for specific tasks, and for example, a specific domain like code generation, like layout generation that we also have at Wix, we are using fine-tuning. So we are still using these techniques, but for knowledge-based questions, for question answering, for injecting facts into the models, actually, I would recommend going with other knowledge techniques like RAG, like investing in how to represent your knowledge better, how to represent your data better and more accessible to your models and use them. So if today we are in a stage of just writing scripts like prompts, we are evolving into building information systems that need to integrate with your organization data more and more. So all this work is done thanks to the amazing team at Wix, available from, have also research engineers, also data curation, also Q&A. All of this is supported by an amazing engineering platform that allows us to, train our models, serve them, and they are actually still looking for good talent in the field. So if you are interested, the team is here, sitting here. Go and search us, and thank you very much.